This is very, very important. Because a problem like this, if it shows up on the test, if you don't pay attention to what we're doing in class today and you don't practice it, it's going to be a question that you don't even know how to start. Alright? Because it's not asked in a way that's conducive to being like, oh, I'm going to use this identity, I'm going to do this. So this is something we need to pay attention to and we need to practice. It says find the exact value of sine alpha plus beta, given that we know sine alpha equals negative 3 over 5 and cosine beta equals negative 1 over 3. And alpha is in quadrant 4 and beta is in quadrant 3. Before I get into anything, what's important about knowing quadrants? Why do problems ever tell you that what quadrant it is now?
Positive and negative.
To tell you whether you have a positive or negative in that particular given thing. Alright, so it says I want to find the exact value of sine alpha plus beta. So just knowing that, I need to know that sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. And the reason why I need to know that is because they want the exact value of that. To find the exact value of that, if I knew sine alpha, cosine beta, if I knew cosine alpha and sine beta, I'd already have the answer. I would just plug those values in. Well, guess what? We know sine of alpha. We know sine of alpha equals negative 3, let me highlight just a number, negative 3 fifths. So that means this sine alpha here is actually negative 3 over 5. I could plug that in right now if I wanted to. We also know that cosine of beta equals negative 1/3. So that means I could take this and plug that in there. The unfortunate thing is that just gets me these two. I still need to find my cosine alpha and my sine beta to finish this problem. Like I have to have something that's written that says cosine alpha equals 4 and sine beta equals 6, plug everything in, solve it, and we have an exact answer. Unfortunately, we're missing those two things. The good thing is with sine and cosine, we always know that sine squared plus cosine squared equals 1. So let's focus on this. I need to find cosine alpha. That's one of the values I need to find. I know sine alpha, I know cosine beta, I need to find cosine alpha. To find cosine alpha, we're just going to say, well, I know that sine squared alpha plus cosine squared alpha must equal 1. But hey, I already know sine alpha. So we're going to plug that negative 3/5 in for our sine alpha. So rather than writing sine alpha, I'm going to write that negative 3/5. It's got to be squared. Plus our cosine squared alpha. Well, that has to equal 1. Now I just need to solve for cosine alpha, and we're good. So I'm going to square this side. A negative times a negative is a positive. 3 squared is 9. 5 squared is 25. Plus cosine squared alpha equals 1. I'm going to subtract both sides by that 9 over 25. So that's going to give me cosine squared alpha equals, instead of 1, I'm going to write 25 over 25. It's just going to save me a step because I already know that I'm subtracting 9 over 25. Might as well make the denominators the same. And we're going to see that we have cosine squared alpha just equals 25 minus 9, which is 16 over 25. Take the square root of both sides, and we're going to come up with cosine alpha equals plus or minus. Well, let's not even do the plus or minus right now. Let's be good pre-calc students and immediately say, well, what quadrant is alpha in? Well, it says alpha is in quadrant 4. In quadrant 4, is cosine positive or is it negative? Yeah.
It's positive.
It's positive, so our answer is going to be 4 over 5. And it's positive because it's in quadrant 4. Well, I'm 3/5 of the way done, because now I know that cosine alpha is 4/5. So we're done with that one. The only thing I need to find now is sine beta. So that's why we have so much room. I'm just going to say done with that. Put a little section there. And I'll start on my sine beta. So we're going to do the exact same thing. To find sine beta, I need to remember that the equation sine squared beta plus cosine squared beta is going to equal 1, but I already know cosine beta. So we're going to say sine squared beta plus, well, I have negative 1/3. I'm going to square that baby, equals 1. We're going to have sine squared beta plus, well, the negative times a negative is a positive, so it's going to be positive 1/9. That's not a 9. That was like a 4. 9 equals 1. Well, all basic algebra. I just moved that 1/9 to the other side, which is going to be, I'm going to change that 1 to 9/9 minus 1/9. Well, that's just going to equal 9 minus 1 is 8/9. And if I took the square root of both sides, we're going to see that sine beta equals square root of 8/3. Is there a perfect square that goes into 8? I see Lewis has 4 fingers up. I assume that means 4, right, Lewis? Yeah. All right. Yep, it's 4. So we could rewrite this as square root of 4 times square root of 2/3, which actually equals 2 square root of 2/3. Now I'm going to ask myself a very important question. What quadrant is beta in? 3. Is sine positive or negative in quadrant 3?
Negative.
It's negative because it's, right, if I'm facing you guys, it's all students take. Tangent is the only one that's positive there, so this must be negative. It has to be negative. And let me move that out a little bit. In fact, how about I just do this? I just say sine of beta equals negative 2 square root of 2/3, and it's negative because of we're in quadrant 3. We now have all of our bits and information that we need. Now we just need to fill it in. Well, sine alpha, let's just put the whole thing, sine alpha plus beta is going to equal, maybe I'm going to write down below just because I don't have a ton of room. It's sine alpha. Well, sine alpha is equal to negative 3/5 times cosine beta. Cosine beta is negative 1/3 plus our cosine alpha, well, that was 4/5. And finally, our sine beta, well, I didn't circle it, but our sine beta is that negative 2 square root of 2/3. Now we just continue on. That's going to equal negative 3 times a negative 1 is going to be a positive 3/15. Plus 4 times a negative 2 is a negative 8 square root of 2/15. My final answer is going to be 3 minus 8 square root of 2/15. This could potentially be simplified further, but we're not going to, because we could separate this into 2 fractions and 3 divided by 5, but it really doesn't simplify it further. This is fine. This would probably be in a multiple choice thing, as is, because the simplified form really isn't that much more simplified. Any questions about any of those steps? So as you can see, it's a lot of work, but it's nothing that's hard work. It doesn't take a lot of brain power once you understand that it's sine squared plus cosine squared, that's all you're asking to do. We've done this a billion times already. Maybe not a billion, I'll say 500 million. Because we did this in the last chapter. We already did this once in this chapter. We're just doing it again. All right? But like I said, if you do not study this, if you do not take this homework seriously, you do not study for the test on this question is going to result in a giant question mark where you're like, I don't even know what to do. Because it doesn't look like anything else really that we've done. All right? So make sure you study this particular question. At least you have a fair shot at it. If you studied it, you're like, okay, I remember it has something to do with sine squared plus cosine squared. Give yourself at least a fair shot to do all of the problems on the test. And this is one of those key ones that... Can you picture yourself on the test reading this question and being like, I don't know what they're asking for? Like when you first looked at that question, wasn't it kind of like, I can't do that. I don't have the skills to do that. If you ever come to a question like that, that's probably a good one to star and say, I need to practice this one. All right, the last thing. We're verifying identities again. We're verifying identities using the sum and difference identities. And on the test, I would specify, all right? So you're not always trying to use the sum and difference. I'm going to put on there like a section that says use the sum and difference identities to prove this. You automatically go, all right, sum and difference identities. So the key with that is, otherwise you're trying to go through all your identities and you're like, I'm not sure what to do. All right, so if I tell you to use the sum or difference identity, I'm going to look at this side and say, hey, that's a difference. That is my cosine difference. All right, so I'm going to go ahead and work on this side. I'm just going to work on this side in the beginning. All right, so I'm going to rewrite that using the cosine identity. The cosine identity is cosine of our alpha, which is x, times cosine of that second value, which is pi over 2. Now the cosine identity is weird because the difference one is actually, I add. All right, the difference one actually is adding between. I'm going to go ahead and shift this over just a little bit. I feel like I got a little overzealous where I put it. There we go. So that's the weird one. We use an addition sign in between it. And then we just use the sine of that first number times the sine of the second number. I'm going to give you a quick reminder once again. We always use just the terms. This negative sign only tells us what to do between. I'm not going to put a negative pi over 2 here. You're going to get it wrong. All right, so do not use a negative. Both of these should be positive. Okay, now we're going to keep simplifying. Well, I have cosine of pi over 2. What is the cosine of pi over 2? That's that one that's straight up and down. That point up there. I'm looking for the x value. Alex has got it. Michael's got it because he's looking at me through it. Ethan, you want to say it out loud?
0.
It's 0. I had some eyeballs. 0. So that's actually 0. So if that cosine, let's actually do all the steps. Cosine x times 0, well, that's going to cancel out. Plus sine of x, sine of pi over 2. If cosine 0, that must mean this is 1. So this side actually equals sine of x. Maybe I'll throw some equal signs in there. So in the book, they may want you to build this up to this, but this is how I'd solve this one personally. I would see sine of x. I can't simplify it any further. I could only change it to 1 over cosecant, but that's not going to help me. So I'm going to work on this side, all right? I did as much as I can on this side. I'm going to look at this side. I'm going to rewrite this side. And the easiest thing to rewrite, all right, the thing I'm going to change is that tangent. So if I have cosine x times, I'm going to rewrite tangent as sine x over cosine of x. My cosines would cancel out, and this side would just equal sine of x. Those two sides are equal, and you are done. I'm going to give you a little bit of hints for your homework really quick. They're really strong hints. Always start, if we're doing the sum and difference, I will start with the ones that you can do the sum and difference of without changing it. So if we're looking at here, this looks like part of a sum or difference, but I would do the one that's this one, because this is straight up a cosine sum. So I can change that to cosine times cosine minus cosine cosine, and we'll split it apart, and it's going to turn right into that. Well, real easy. The hard one to see is this one. I'm going to tell you right now, you're going to do that side. We're going to work on that left side. As odd as that seems, it's because this, I can't do anything with the difference. Is this a sum and difference, though? Can we change this into a sum or a Jack, you're shaking your head. Yeah. What would you change this to? Were you just agreeing? Or no?
I was agreeing, but couldn't you do like cosine x plus x or something?
If you do that, you'll get the answer. So I was focused on the ones that, like this one, I would do these. I would do the sum of this one, the difference of this one. I wouldn't focus on this side. So I always do the ones that you can just, this one I'd focus on that, and then I would put that right next to it. Okay? So work smart on these. Do the ones that are just easily put into those sum or difference identities. All right, any questions from this guy, for this guy? Not from me, I can ask questions all day. Any questions? Test is on Friday. That means, yes. But you should already know most of it. We already did the identity one. The only thing you have to really add to it